start today's lesson with a lot of vocabulary around volume. So to follow along, make sure you're marking your text with your highlighters as we go through these different terms. You're going to come back to these a lot. We're going to start with what we call a geometric solid. So a geometric solid is bounded three-dimensional geometric figure. Normally, when we talk about geometric solids, the most common are what we call polyhedral or polyhedron. This is a three-dimensional solid figure made up of polygons. Okay? Within that polyhedron or polygon, you've got three major vocabulary terms. The first one is the face. The face is one of the polygons that makes up a polyhedron. So when we talk about the face, we're talking about this portion of it. That's the big part that you're seeing. That's what we call the faces. The next part is what we call the edge. An edge is the intersection of two faces of a three-dimensional figure. So my edges are these spots. Okay? Those are what we call edges. That is where those two faces come together. So there's two examples of edges. Okay? The edges are those lines that are formed where those faces come together. The next one is what we call the point where the multiple edges meet, and that is known as the vertex. So our vertex are these points. So our vertexes come down to a single point where three faces join together. Or three, yes. Okay? So our vertex is a single point. Our polyhedrons are made of different faces. When the faces come together, they form a line that we call an edge. When the edges come together, they form a point that we call a vertex. Are we okay on those so far? Okay? Now, we do have a special 3D figure, and this is one of Dodia's favorite things. They love unit cubes. They're going to be on just about every test that you take. So we need to understand this concept. But a unit cube is one whose sides are all 1 unit long. Now the key there is 1 unit. A unit can change, but they're all going to be the same. Yeah? That's right. Let's get right now we're looking at a lot of vocabulary. We need to wait a minute. Okay. We also have a couple special ones. A right rectangular prism is a polyhedron with 3 pairs of congruent and parallel rectangular faces. The reason it says 3 pairs is whatever this face is, that one on the back side is going to be exactly the same. So this one is the same as the one that's on that back side. This side is the exact same as this side. This one is going to be the exact same as this one. So they're all going to be identical. Okay? Figure B is a specialized rectangular prism called a cube. This is a polyhedron that has congruent squares as faces. Rubik's did a great job for mathematics by introducing the cubes, and now everybody knows what a cube looks like. Rubik's cube is a cube. Okay? Any questions on any of this vocabulary? A lot of terminology you can see that. Okay? So make sure you understand it. We're going to get, we'll see what you're going to get on the handout so that you'll have all those terms for the testing that we'll be doing. One thing we haven't given you yet is your formula. Okay? If I am doing volume, it said, well, find our volume, all we're going to do is multiply the length times the width times the height. Yeah. Hold on a second. So what we're going to do is, on our tank, we're going to label our length with our height. Which number do you guys think will be the length? Are you okay with that? Okay, what about the width? 25? What about the height?
30.
Everybody okay with that?
Yeah.
Quick side note, does it matter?
No.
Why not?
Because it's the same number.
I say number is big enough. 25 the word.
It don't matter how you.
Probably something.
It's cubic.
Nope. Okay. Community property multiplication. Yes, you have to say it all. Because there's no community property as division. No community property as subtraction. There's only community property as addition for community property as multiplication. You have to say the whole thing. You have to say community property. It doesn't apply to all operations. It is specific to the operation. That's what we're going to do next. So, how can I determine the volume? How many cubic inches of water can it hold? Then they give us a word problem to work. We give you guys about 5 minutes to work through these three. Try to do it on your own, then compare answers at the table. Because it's all multiplication, you're probably multiplication, so it's going in. Yeah, you have 5 minutes, go ahead and start. Okay, our first one, how can I determine the volume of the tank? Isaac? Isaac, all right. Multiply length times width times height. So how many cubic inches did we get?
30 inches.
Formula, we would say 50 inches times 25 inches times 30 inches. Does it matter the order I do it in?
Yeah.
Well, so personally, I would have started at 50 times 30. So I can do that one in my head, that's 1,500. Then times 25. So 5 times 0 gives me 0 for both those. 25 carries a 2. 5, 6, 7. Guys, don't forget your placeholder. I see a lot of kids making mistakes by not doing that placeholder. I moved to the tens, I need to have a 0 as my first number. Now I'm doing 2 times each of the zeros. 2 times 5 is 10, carry 1. 2 times 1 is 2, plus 1 is 3. Out of my column, 0, 0, 5, 7, 3. So the volume is
Inches.
It's huge.
Inches.
All right.
Stop talking.
Hit this again
Thank you.
to make sure that everybody understands why this is important. This is actually critically important. Okay? This is 1 inch. This is 1 square inch. Those look the same. No. This is 1 cubic inch. Do those look the same? No. So this says inches squared. Correct answer? Absolutely not. If it says inches, is that right answer? Not even close. So is it important to have your units correct? Absolutely. Those are completely different, guys. You have to be very accurate in what you're putting. Okay, our next one, a planter box, the shape of a rectangular prism, has a length of 3 feet and width of 1 foot, a height of 1.5. How much potting soil can it hold? We go straight back to our formula. Length times width times height. I will tell you that for checking multiple homework. I have a ton of kids who don't want to write this down. Does that take much work? No, but the kids that aren't writing that down are the ones that are getting the problems wrong. Especially when it comes to stuff like trapezoids and triangles. You have 1/2 in there, so they'll just multiply the numbers and get that 1/2. Guys, write your formula. This is going to make sure you get it right. This is not hard to do. But if you'll take this step to make sure you're accurate, the rest should be very easy. Now, literally, all I'm going to do, I've got the length, width, and height pointed out for me. My length is what? 3 feet. My width is, my height is, okay? Uh-oh, I have a mixed number. That means I need to do what? My decimal. Power fraction. So we're going to slam dunk, right? Multiply, then add. Because I'm making this into an improper fraction, I need to do that for all of my numbers. How do I make a 3 an improper fraction? 3 over 1. How do I make a 1 an improper fraction? 1 over 1. 2 times 1 is plus 1. 3. Don't forget to keep the denominator. Okay? So reductions I can do. So I'm just going to multiply. 3 times 1 is times 3. 4 times 1 times 2. 9 bigger than 2? Yep, so I need to simplify. 2 goes into 9. 4 times with 1 left over. Okay? So here's the number. What kind of problem is it? What problem? I don't need to answer it.
The pantry box can help.
So like everything except I missed something. 4.5 what? Cube. Where? We're doing volume. Volume will always be cubed. Length has a width has a height. Units are multiplied. Cubic feet of potting soil. Everybody understand how this all works? Does that make sense so far? Okay? Yes. Multiplying? Okay, so multiplying. So I started at 50 times 30. So you can probably multiply this one what I want. Right? 5 times 3 is 15, 2 zeros. So that became 1,500. And I just multiplied by that third number 25. That makes sense? So I took that shortcut. So 50 times 30, that's 30. And that was multiplied by 5. Okay, let's go to our packet. Packet here, you guys. The more often you do something, the better it sticks in your head. Even though we just did it in the book, we're still going to do it on this paper.
Everybody has their paper.
Everybody remember what our definition of a polyhedron was? After? 3D figure made out of polygons. The fact that the polygons mean that they've got to be enclosed. Okay? So a polyhedron is a 3D figure made out of polygons. In other words, it's a regular shape that I can actually make and it's bounded on all sides. Now, we also gave you additional definitions. The first one was, what do we call this whole piece over here? What's the word for that? Base. shape on the side. And by sides, I mean all sides. Top, bottom, left, right. All of them are called faces. Okay? What about the line that is formed when two faces meet? What do you call that?
Edges.
The edges. What? And the edges are always going to be a line. That's what is a circle, but still form the line. It's line that lines a circle. And then the last one that we've already given you, where those edges meet, is called the vertex. The vertex is always going to come down to a single point. So those single points on the edges, where those edges meet, that is what we call the vertex. Now, what we haven't talked about yet, and this can change based on how you're orienting your figure, but normally that bottom one has a special name. We know we call that bottom side. Heard it. That's called the base. No, it's called the base. That is the figure at the bottom of the polyhedron. Okay, so a lot of terminology there. Now, in three-dimensional figures, there are two primary figures we're going to be doing a lot of work with. That is prisms and pyramids. So some things about them are the same, but there are some differences between them. One big thing on each of them, these are both going to be 3D figures. The prisms and pyramids, those are three-dimensional. You're going to see them in 3D. Another big one. When we name a prism or a pyramid, we have to pay special attention to our base. They are named by the base figure. That is true for both prisms and pyramids. You have to be able to figure out what that base is. Our next one is where we start to get into differences. And that is based on the size of the figure. In a prism, such as the one we have pictured up here, what shape, if we call this our base, what kind of shape are we on these other sides? Rectangles. So the sides on a prism are rectangles. We don't have one pictured here, but if I were looking at a pyramid, what shape are the sides on the pyramid? Triangles. That is a big difference between prisms and pyramids. Sides are triangles. It can be. You also have rectangular, you also have triangular pyramids. So again, you also have your base shape as the LP name, which is kind of the next one. Because all of the sides on my prisms are rectangles, that's how many bases I have.
6.
2. Because my sides are rectangles, whatever's on the faces, there are going to be two of them. Those two bases will be identical. How many bases do you think we have on a pyramid? One, because closing the base is going to be a vertex. Because all those other triangles will come together. There's only one base on a pyramid. So when we are naming them, some examples. On pyramids, we can have rectangular pyramids, like the one they have printed, shown here. Prism, not pyramid. You can also have a triangular prism, and that's one that gets kind of tricky, because all of a sudden it's like I'm seeing triangles, and a lot of people think pyramid. Not. Two sides are triangles, but all the rectangles and cubics are a triangular prism. We did talk about a specialized one. All the faces are the same. What do we call that? A cube. So a cube is a very specialized rectangular prism. Okay? On our pyramid, kind of have the same thing. I can have a rectangular pyramid. This means that my base shape is a rectangle that all the sides are coming up. I can have a triangular pyramid. In that case, all of the faces are going to be triangles. And you also have a square pyramid. So that's one of the most common. Those are just a few different examples of the types of prisms and pyramids that we can have. The biggest thing on this, you have to recognize what your base is. That's going to be part of the name. And then you got to figure out what the sides are. Once you've identified your bases, that's going to help you identify the sides to determine if you're looking at a pyramid or a prism. The other big one is one base versus two bases. I've got two of the bases that tells me I'm looking at a prism. Pyramid is always going to have a base and a point on it. Okay, so now we're going to use that for practice. When we find the value, one thing you can do is I can look at just the area of the base. Then I can multiply that by the height. And what it's saying is, okay, I've got this box, I've got this rectangle on the bottom, but I'm stacking that rectangle this many times. How much can I then put inside of it? So, you can find the area of the base, and then multiply by the height. Do you have to do it that way? Well, because I can use length times width times height to do it any order I want to make math easier for myself. Again, which property is that? And all computer property of multiplication. We've got two problems to do. We'll give you guys about 5 minutes to knock these two out. Let's get started.
All right, guys, let's go over these. So let's start with the top one. What is our volume formula? Length times width times height. So what is my length? Three feet times what is my width? 1.5. What is my height? 2 feet. Guys, I don't know about people well, you know this. I'm going to start with my whole number. 3 times 2? Okay. So I have 6 feet times 1.5 feet. So I'm going to work that out here. 6 times 5? 6 times 1? Plus 3? There's one number after the decimal, so there should be one number after the decimal in my answer. So I get 9 feet cubed. Any questions about that one? All right, the bottom one is also length times width times height, yes? Yes. Your math teacher thinks it's funny.
Well,
It is very
what do you do?
Will you tell Vandermeer yes, please? Thank you. All right. What is my length? 8 inches. Times what is my width? Times what is my height? Now I had a student that said 16 times 8. What did they do wrong?
They added a pattern.
They added 8 plus 8 instead of multiplying 8 plus 8. What is 8 times 8?
64.
So 64 times 8. 8 times 4 is
4.
8 times 6 plus 3.
51.
So you get 512 into here. Any questions? Are we getting it now? Good, because we're about to make it a lot harder.
back in your books. So one way to calculate the volume of a prism is by what we call a cube. So if I pack it in unit cubes, I can figure out what the volume is based on how many cubes it takes. So what we do on this, if I do pack the prism 7 unit cubes along its length, 3 unit cubes along its width, 5 unit cubes along its height. So all they're done, and you sit here. 1, 2, 3, 4, 5, 6, 7 cubes go this way. How long would you do those cubes within? And then I've got 1, 2, 3 go to the back. How long would you do those? 1 inch. I've also got 1, 2, 3, 4, 5 heading up. 1 inch. So that's what we call a 1 inch unit cube. Every side is 1 inch. Does that make sense? Okay. So now let's talk about how many it takes to pack up this entire thing. If I've got 7 across the bottom and 3 across the length, how many total cubes is in that bottom length?
21.
21. So there are 7 times 3, or 21 unit cubes in each layer. And there are how many layers? Okay, 5. There's 5 layers. So the total then would be that 21 times the 5 layers, or 105 unit cubes. So the volume is 105 cubic inches. That makes sense for you.
Yes, sir. Yeah.
Okay. So let's consider the formulas for volume of a prism and area of a rectangle. Everybody agree? Volume is like times with that height. Hope those people work as hard as me to figure that out. We've also been working with area for the last 2 weeks. You know, that's just our length times the width for a rectangle. Good on that. Okay? So, if I use B, a capital B, to represent the area of the base of a rectangular prism, then I can redo the formula for the area as, instead of an A, I'm going to say, okay, now I'm looking at this base. So the line with that is going to be length times width. Everybody okay with that? So I can say B is length times width. The area of the base. Everybody okay with that? So if I now say that L and W is just that capital B, the area of the base, I can now rewrite my formula and saying the area of this base, however much it takes there, times that height. And that will still give me the volume. Does that make sense? That's all the formula says. Take the area of the base, multiply by height. Find the area of the base by doing like times width. So how does this work? How does this relate? The base has 21 cubes. 7 by 3. So I multiply that by 5 layers to find the total number of cubes. All I'm doing is putting in writing what we just done mathematically. Okay? We took those 21 cubes we found down here on this base layer. I said, well, every layer is going to have that same number of cubes, correct? And all I'm doing is I'm putting 5 layers of those cubes, get all the way through that entire prism, figure out how many total cubes there are inside of it. Make sense? Okay? And all they're saying, the only difference between this formula and this one is here, I have more flexibility. I've got a copy of multiplication. I can multiply them in the order I want to. Here, they're saying, well, you find the area of the base first. So basically, for the person asked for this formula, because it gives me more options. But if I ask you to use this formula, you're going to have to use it. Okay, now, using both of these formulas, you can rewrite the formula for the volume of a rectangular prism as B equals BH, where B represents volume, B represents the area of the base, and H represents the height. So everybody's okay with that, yes? Any questions about it? Okay? The biggest deal, if you see the capital B, that's talking the area of the base. But anytime we did area, for example, the area of a parallelogram, base times height, right? If it's lowercase b, that's just talking about one measure, the length. And with the capital B, it's talking strictly about the area of the base. So big B meaning they're multiplying it. Now, let's look at a cube that has side lengths that are each 1/2 of an inch. Now, each side of the half-inch cube is half the length of a unit cube. So it takes 2 of these cubes to measure the same length as a 1-inch cube. Does that make sense? Well, after we did it, and then we did this, like, make something do this first and then show them. So, what I'm saying is, instead of being 1 inch long for my unit cube, now each one is a half-inch long. So it's not going to take 4, then we get that full inch, right? Does that make sense, everybody? Okay. So now the question is, how many half-inch cubes does it take to fill the prism from the work example? Philip says it will take twice as many cubes to fill the prism. Mara says it will take 4 times as many cubes. And Daniel says it will take 8 times as many cubes. Who is correct? So we give you guys about 3 minutes to talk about this as a group. Tell me, who do you think is right? Philip, Mara, or is it Daniel? Then we're going to break you into groups, and we'll show you what the answer is. So talk about it in a few minutes. Write down who you think the answer is. Okay, we just working with you guys. Unit cubes, how changing that side measurement changes the number of cubes you need to get to 1 cubic inch, right? So, given these, who do you now think is right? Write down. When we switch to that half-inch cube, I now need 2 across, I also need 2 deep, and I need 2 high. That means there's now 8. So Philip is correct.
What? Daniel.
Daniel is correct. I'm just seeing if you guys are paying attention. Because each 1 unit cube now needs 8. You fill it. something. Okay? So bottom line, guys, as I switch how many cubes I need to get to that 1 cubic inch, that is going to exponentially change how many I need to fill the total area. So in my group, we went to the 2, we took 8. How many did it do when we went to 3? 27. So given that pattern, you think you can tell me how many it would do when we did 4? 64 times. 4 times 4 times 4. Okay? Okay, let's go back to our packet. Okay, we do our first 2 together on this one. That said, each one of these cubes is 1 inch. So I can use my figure and I can now count if each cube is 1 inch, how far long is this on my length? Each one is 1 inch, so this is 4 inches. Our width is 3 inches. Our height is 2 inches. So I now know that my length is 4, my width is 3, my height is 2. Using our formula, D equals LW8, I can now put those numbers in. 4 inches times 3 inches times 2 inches. 4 times 3 gives me, 12 times 2 gives me 24 what? 2. So my volume equals 24 inches cubed. Does that make sense, guys? Okay, now here's where they're going to throw up a twist at you. Now I'm going to change my key. Now how long is each one of those blocks? 1/2 inch. So if it's a 1/2 inch, this is now 1 inch, this is 1 inch, so that total is now 2 inches. This is 1 inch, half, so my width is now going to be 1.5 inches. My height, I've just got 2 of them, so that is, does that make sense for everybody? I find volume formula change. No. If my numbers change. Yes. So now I put my new numbers into my formula. Uh-oh. I've got a number. What do I have to do? But, because I need to turn this into a proper fraction. I need to make all of them in proper fraction. How do I make a whole number in proper fraction? Put it over a 1. Add a 1. Okay, 2 times 1 is 2 plus 1 is 3. So it's now 3 halves. How do I make 1 into a whole mixed number? Put it over 1. I have 1 reduction. I've got a 2 on top and bottom. 3 times 1 is 3. 1 times 1 is 1. If you're on action, you didn't do reduction. 3 times 3 is 6. 1 times 2 is 2. 6 divided by 2 is 3. Did I get the same answer? Do not forget your unit. Good. This one equals 3 cubic inches. Okay, you got 3 more to do. They're changing the length of each of your keys. Realize the picture didn't change. All that changed is how long each of those cubes is. So you got 3 more problems to do. We'll give you guys about 7 minutes. Go. Okay, so we're going to just look at all we're doing, guys. We're changing what each cube equals now. So now, 4 inches. Now it's a 1/4 inch. How many of them do I have? 4. 4/4 comes 1 inch. Going by width, I have 3 of them. Each one is 1/4, so that is now 3/4 inch. Going up, I now have 2 of them, so that's 2/4, which equals 1/2. Again, start with your base formula, length with height. 1 inch times 3/4 times 1/2. Doing just the numbers. So 1 to make it a proper fraction, just put over 1. 3/4, 1/2. Another simplification. So 1 times 3 is, times 1 is 3. 1 times 4 is, 4 times 2 is. So my answer is 3/8 cubic inches. Figure out the correct unit. So that is inches times inches times inches. So there are 3 of them. Now I've changed it to a 1/3 inch. So each one of these is now 1/3. So 3 of them gets me to 1. And then I have another one left over. So that makes a length of 1 1/3. And now 3 of them makes 1 inch. So that's just an inch going across. Going up, I've got 2 of them. That gives me 2/3. Putting them in my formula. 1 1/3 times 1 inch times 2/3. And now I need to slam dunk. That becomes 4/3 and 2/3. 4 times 1 is times 2. 3 times 1 times 3. 9. And our third one. Now we're all the way down to 1/8. I've got 4 of them, so 4/8, 1/2. Going to width, I've got 3 of them. Going up, I've got 2 of them, so 2/8, same as 1/4. So we're using our formula again. 1/2 inch times 3/8 times 1/4. I'm pulling out my numbers. 1/2, 3/8, 1/4. Don't have any reductions I can do, so 1 times 3 is, 3 times 1 is 3, 2 times 4 is 8 times 8. I could have done 2 times 8 is 16 and 16 times 4, but it's easy to do 8 times 8. Well, I use the community copy multiplication to try to make it easier. So my answer there was 3/64 cubic inches. So you guys see how when I change what my unit cube is, it completely changes the volume of figure. And given the example we showed for reacting stack, you can see how that relates to 1 cubic inch. And if I use those fractionals, it really becomes exponential how they change within them. Okay? So that's where we'll finish for today. Your homework is out of math yet. Quarter ends tomorrow. Putting in all your final grades in tomorrow, guys. Luck on this.